The National Electrical Code, specifically Article 430.110, addresses main disconnects. This article states in sight from the controller location, a disconnecting mean shall be located in each motor control circuit as close as practicable to the controller. This means the NEC requires a disconnecting means, also known as a main disconnect, to be in sight from the controller location. The code doesn't explicitly mandate that this disconnecting means be physically attached to the motor control center, abbreviated MCC. In industrial facilities, it's a common and accepted practice to locate the main disconnect for motor control centers on a separate panel or even in a remote location. This practice often enhances access and safety during maintenance and servicing procedures. Given the NEC interpretation and prevalent industry practices, it is acceptable to have the main disconnect located remotely from the motor control center, provided certain conditions are met. Firstly, the main disconnect must be lockable in the off position. Secondly, the main disconnect must be within sight from the controller location or accessible from an adjacent area without needing to move the controller itself. In this specific scenario, the responsibility for providing a lockable main disconnect that adheres to the NEC requirements falls on the customer. Therefore, it's entirely reasonable to request reimbursement for the cost incurred in installing the main disconnect. Your understanding is correct in that providing a main disconnect doesn't constitute a violation if the device feeding the motor control center is lockable in the off position and within sight. However, and this is crucial, consulting with the local electrical inspector is strongly recommended. This consultation serves to confirm compliance and ensure adherence to all local regulations. Let's delve deeper into the implications of Article 430.110. The phrase "in sight from" is pivotal. The NEC defines "in sight from" as being visible and not more than 50 feet distant from one another. Therefore, the disconnect must be readily visible from the controller location and within that 50-foot range. The term disconnecting means refers to a device or group of devices by which the conductors of a circuit can be disconnected from their source of supply. This disconnecting means must have an adequate interrupting rating for the available fault current at its terminals. Now, regarding the lockable requirement, this is crucial for safety during maintenance and repair. The disconnecting means must be capable of being locked in the open position to prevent accidental or inadvertent energization of the circuit while work is being performed. The NEC doesn't explicitly dictate the type of disconnecting means to be used. It could be a circuit breaker, a fuse disconnect switch, or another suitable device. The selection of the appropriate disconnecting means depends on factors such as the voltage, amperage, and the available fault current. Moving on, let's consider the practical implications of a remote disconnect location. While the NEC permits a remote disconnect, it's important to assess the potential hazards and ensure that adequate safety measures are in place. For example, clear and conspicuous labeling should be provided at both the motor control center and the remote disconnect location to identify the associated equipment. Procedures should be established to ensure that the disconnect is properly locked out and tagged out before any work is performed in the motor control center or the connected equipment. Now let's talk about situations where a remote disconnect might be advantageous. In some industrial facilities, motor control centers are located in areas that are difficult to access or that are environmentally harsh. In these cases, locating the disconnect remotely can improve accessibility and reduce the risk of damage to the disconnect. Also, in large facilities, it may be more efficient to group disconnects in a central location rather than having individual disconnects for each motor control center. This can simplify maintenance and troubleshooting. However, even with a remote disconnect, it is important to maintain clear communication and coordination between personnel working at the motor control center and those operating the disconnect. Now, let's consider the customer's perspective. While the customer is ultimately responsible for ensuring compliance with the NEC and other applicable codes and standards, it's important to have a collaborative approach. Open communication and a clear understanding of the requirements can help to avoid misunderstandings and ensure a successful installation. It's also important to document all agreements and decisions in writing to avoid disputes later on. When requesting reimbursement for the cost of the disconnect, be prepared to provide a detailed breakdown of the costs involved. This should include the cost of the disconnect itself, as well as any labor or materials required for installation. Now, it is important to re-emphasize the importance of consulting with the local electrical inspector. Electrical codes and regulations can vary from one jurisdiction to another, so it's crucial to ensure compliance with the specific requirements in your area. The electrical inspector can provide guidance on the proper installation and operation of the motor control center and the associated disconnecting means. They can also help to identify any potential hazards or code violations. Moreover, the electrical inspector's approval is typically required before the motor control center can be energized and put into service. This approval serves as verification that the installation meets all applicable codes and standards. Now let's talk about situations where a main disconnect might not be required at all. The NEC provides some exceptions to the general requirement for a disconnecting means. For example, a disconnecting means is not required if the motor control center is supplied by a branch circuit that is protected by an instantaneous trip circuit breaker. An instantaneous trip circuit breaker is a type of circuit breaker that trips instantaneously in response to a short circuit or ground fault. This type of breaker provides very fast protection and can help to minimize damage to the motor control center and the connected equipment. However, it's important to note that the use of an instantaneous trip circuit breaker is subject to certain limitations and requirements. The NEC specifies the maximum allowable settings for the instantaneous trip element and requires that the breaker be properly coordinated with other protective devices in the system. Also, in some cases, a disconnecting means may not be required if the motor control center is part of a larger system that has a readily accessible main disconnecting means. For example, if the motor control center is located in a factory that has a main disconnect for the entire facility, an individual disconnect for the motor control center may not be necessary. However, this exception is subject to certain conditions and limitations. The main disconnect must be readily accessible to authorized personnel, and it must be capable of disconnecting all of the power to the motor control center. Also, clear and conspicuous labeling must be provided at the motor control center to indicate the location of the main disconnect. Now, let's discuss some of the common mistakes that are made when installing main disconnects for motor control centers. One common mistake is failing to properly size the disconnecting means. The disconnecting means must have an adequate interrupting rating for the available fault current at its terminals. If the disconnecting means is not properly sized, it could fail to interrupt a fault current, which could result in damage to equipment or injury to personnel. Another common mistake is failing to properly install the disconnecting means. The disconnecting means must be installed in accordance with the manufacturer's instructions and all applicable codes and standards. It must be securely mounted and properly grounded. Also, all electrical connections must be properly made and tightened. Another common mistake is failing to properly label the disconnecting means. The disconnecting means must be clearly and conspicuously labeled to indicate the equipment that it serves. The label should be durable and weather resistant. It should also be easy to read and understand. Another common mistake is failing to properly maintain the disconnecting means. The disconnecting means should be inspected regularly to ensure that it is in good working condition. Any damaged or worn parts should be replaced promptly. Also, the disconnecting means should be tested periodically to verify that it is operating properly. Now, let's talk about some of the different types of main disconnects that are available. As mentioned earlier, the disconnecting means can be a circuit breaker, a fuse disconnect switch, or another suitable device. Circuit breakers are typically used in applications where frequent switching is required. They are also relatively easy to reset after a fault. Fuse disconnect switches are typically used in applications where infrequent switching is required. They provide a higher level of protection than circuit breakers, but they are more difficult to reset after a fault. Other types of disconnecting means include manual switches, magnetic contactors, and solid-state switches. The selection of the appropriate disconnecting means depends on the specific application requirements. Now let's discuss the importance of coordination. Coordination refers to the selection and arrangement of protective devices in a way that minimizes the extent of an outage when a fault occurs. The goal of coordination is to ensure that only the protective device closest to the fault trips, while other protective devices upstream remain closed. This minimizes the impact of the fault on the rest of the system. Coordination is particularly important in industrial facilities where a single outage can disrupt production and result in significant financial losses. To achieve proper coordination, it's necessary to perform a coordination study. A coordination study is a detailed analysis of the electrical system that identifies the appropriate settings for each protective device. The study takes into account factors such as the available fault current, the characteristics of the loads, and the desired level of selectivity. Now, let's discuss the importance of grounding. Grounding is the process of connecting electrical equipment to the earth. Grounding provides a path for fault current to flow back to the source, which helps to trip protective devices and prevent electrical shock. Grounding is required by the NEC for all electrical equipment. The NEC specifies the minimum size of the grounding conductor and the methods for connecting the grounding conductor to the equipment. It's also important to ensure that the grounding system is properly tested and maintained. Now, let's talk about some of the advanced features that are available on some main disconnects. Some main disconnects are equipped with advanced features such as remote monitoring, remote control, and power metering. Remote monitoring allows you to monitor the status of the disconnect from a remote location. This can be useful for identifying potential problems before they cause an outage. Remote control allows you to operate the disconnect from a remote location. This can be useful for isolating equipment during maintenance or for restoring power after an outage. Power metering allows you to measure the amount of energy that is being consumed by the equipment that is connected to the disconnect. This can be useful for identifying energy waste and for optimizing energy usage. In summary, understanding and adhering to the NEC requirements for main disconnects and motor control centers is paramount for ensuring safety, compliance, and efficient operation. While remote disconnects are permissible under certain conditions, it is crucial to prioritize safety measures, maintain clear communication, and consult with local electrical inspectors to guarantee adherence to all applicable regulations. Remember to prioritize lockable disconnects, proper labeling, and consistent maintenance to minimize risks and optimize performance. By doing so, you can create a safe and reliable electrical system that meets the needs of the facility and protects personnel. The considerations outlined here provide a detailed framework for navigating the intricacies of main disconnect installations in industrial settings.